Okay, so we're going to be looking at our Chapter 2 review for the midterm exam. There's actually a whole bunch of material in Chapter 2 that we are not going to cover, but we will take a look at some basics of proofs that will help us for other proofs. So we're going to complete this proof where it's given that AB is perpendicular to BC. These two are perpendicular, and 2 and 3 are complementary. We want to prove that angle 1 is congruent to angle 3. Well, what we can do is start with the givens. So I'm actually going to write both of these out first. So AB perpendicular to BC, and angles 2 and angles 3 are complementary, and that's all given. So if 2 and 3 are complementary, that means that angle 2 plus angle 3 is equal to 90. And that's just the definition of complementary angles. Now because A and B are perpendicular, that means they form a right angle. So that means that angle 1 and angle 2 are complementary. And that's because of, we can say, definition of perpendicular lines. And if they're complementary, we can do sort of the same reasons as step 2. I'm just going to copy that down because that means that angle 1 plus angle 2 is equal to 90 degrees. So in step 5, if we know that angle 1 plus angle 2 is equal to 90, and angle 2 plus angle 3 is equal to 90, then we can say that angles 1 plus angle 2 equals angle 1 plus angle 3, and that is substitution. And that means that if angle 1 is on both sides, I can say angle 2 is equal to angle 3, and that is subtraction property. So you can see that going through this, where there are a lot of old postulates and properties that we examined. So we have definition of complementary angles, perpendicular angles, and of course good old substitution and subtraction property. So that gets what we wanted. Angle 1 is congruent to angle 3. Oops, sorry. 1. All right, next up, number 2. We can start with our givens. So we want to prove that PQ is equal to ST. So it's given that PQ is congruent to QS, and QS is congruent to ST. That's all given. So we want to prove that PQ is congruent to ST. Well, we don't really need a picture or diagram for that because we know that PQ is going to be congruent to ST, and that's just the transitive property. So that's a nice basic one to review the transitive property, so make sure that you know that going into some of the more difficult, challenging proofs. And then finally we have this one. So we want to prove that QPR is congruent to TPS, and it's given that QPS is congruent to TPR. So QPS is congruent to angle TPR. Well, angle RPS plus angle QPR is equal to QPS. So that means angle QPS is congruent to angle QPR plus angle, say, RPS. And that's the angle addition postulate. We mostly looked at segment addition postulate, but we can also use the angle addition postulate. Step 3, we're going to do a similar approach, but on the other side. So this is going to be angle TPS, or I guess I could say angle TPR. Angle TPR is congruent to angle TPS plus angle RPS. And yet again, that is going to be angle addition postulate. And so for 4, we can, because we know that QPS and TPR are congruent, we can say that angle QPR plus angle RPS is congruent to angle TPS plus angle RPS. And that's just substitution. Substitution. So technically here, there's some other steps we should say first. We should say that RPS is congruent to RPS. That's a reflexive property. And then we should subtract from both sides, showing subtraction. But really, I can just say QPR is congruent to angle TPS. We don't need to write out a whole bunch of steps for this. And that is, we can say, subtraction property. If you do show the other steps, then this would be substitution, but just leaving it like this is perfectly fine for us. So that's really it for the main parts of Chapter 2. Like I said, there's a lot in there that we're not covering, which is fine. So just make sure that you're familiar with some of these ideas for the proofs. You follow the old tests, the old quizzes of what we had, and you study hard and keep working hard.